Imagine gazing up at the night sky, not at a distant red dot, but at a vibrant blue-green world, a second Earth, teeming with life. For decades, the dream of terraforming Mars, transforming its desolate plains into a habitable paradise, has captivated scientists and sci-fi enthusiasts alike. But is this just a fantasy, or could humanity truly engineer an entire planet? On Orbital Arc, we often explore the boundaries of scientific possibility. Today, we're diving deep into one of humanity's most ambitious proposals, the terraformation of Mars. We'll uncover the colossal challenges involved, from building an atmosphere and creating oceans to shielding a planet from deadly radiation, and ultimately ask, how truly impossible is this dream? For millennia, humanity has been driven by a restless curiosity, a desire to explore beyond the horizon. And in our modern age, that horizon extends to the stars. Mars, our closest planetary neighbor, has long been the prime candidate for humanity's first off-world colony, a potential backup disk for Earth. But beyond simple colonization, the idea of terraforming Mars, making it truly livable, breathable, and self-sustaining, ignites our wildest imaginations. It represents the ultimate expression of human ingenuity, a chance to expand life beyond our cradle, to put all our scientific and engineering might into making another planet bloom. It's not just about survival. It's about pushing the boundaries of what is possible, dreaming of a future where our species is not confined to a single, vulnerable world. The romantic vision of Martian oceans and forests is powerful, but the reality of turning a desolate, frozen desert into a verdant world is an engineering task of unimaginable scale. Before we can even begin to think about transforming Mars, we must first understand the formidable adversary we face. Today's Mars is a stark, unforgiving world, utterly inhospitable to human life as we know it. Its atmosphere is incredibly thin, less than 1% the density of Earth's, composed almost entirely of carbon dioxide. If you stepped onto the Martian surface without a pressure suit, your blood would boil, and your lungs would rupture in seconds. Temperatures plummet to an average of minus 63 degrees Celsius, making the Antarctic seem balmy. While we know there is water on Mars, it's mostly locked away as ice at the poles and beneath the surface, a frozen relic of a warmer, wetter past. And perhaps most critically, Mars lacks a global magnetic field, leaving its surface constantly bombarded by deadly solar and cosmic radiation. Without this shield, any nascent atmosphere would be stripped away over time by the relentless solar wind, and life would struggle to survive the carcinogenic assault. The Martian soil itself is laden with toxic perfluorides, posing another significant obstacle to agriculture. This isn't just a cold desert, it's a cosmic radiation oven with a suffocatingly thin veil of gas. The first and arguably most critical step in terraforming Mars is to thicken its atmosphere and warm the planet. This isn't just about making it comfortable, it's about creating enough atmospheric pressure to allow liquid water to exist on the surface and to retain any heat. The leading strategy involves releasing vast quantities of greenhouse gases into the atmosphere. Mars already has significant reserves of carbon dioxide locked up in its polar ice caps and beneath the surface. The challenge is releasing it efficiently. One concept involves deploying massive orbital mirrors, perhaps kilometers in diameter, to focus sunlight onto the polar regions, vaporizing the CO2 ice. Another idea involves introducing super greenhouse gases like perfluorocarbons, synthetic compounds far more potent than CO2, into the Martian atmosphere. These could be manufactured on Mars using raw materials or imported from asteroids. As the atmosphere thickens and warms, the albedo effect would kick in. Less ice means more dark surface area, which absorbs more solar radiation, accelerating the warming process. This initial phase alone could take centuries, transforming Mars from a frozen wasteland into a slightly less frozen, CO2-rich, and still unbreathable, but gradually warming world. Once the Martian atmosphere is thick enough to hold heat and allow liquid water to persist, the next monumental step is to reawaken Mars's ancient oceans. As the planet warms, the subsurface ice and polar caps would begin to melt, forming vast lakes and eventually oceans. Imagine rivers carving new paths across a once barren landscape. But water alone isn't enough. For Mars to truly become a second Earth, it needs a breathable atmosphere and a functioning ecosystem. This is where biology enters the picture. The introduction of extremophile microorganisms, hardy bacteria and algae, capable of surviving in harsh conditions, would be the first pioneers. These would help break down the toxic perchlorates in the soil and begin the long, slow process of oxygen production through photosynthesis. Over centuries or even millennia, as conditions slowly improve, more complex plant life, lichens, mosses, then grasses and trees could be introduced. These plants would not only generate oxygen, but also stabilize the soil, create nutrient cycles, and contribute to the planet's albedo and hydrological cycle. This phase represents a monumental biological engineering challenge, requiring a profound understanding of ecological succession and planetary-scale genetic engineering. The sheer timescale involved is mind-boggling. We're talking about generations, if not dozens of generations, of human effort before Mars truly becomes verdant. Even if we manage to create a thick atmosphere and flourishing biosphere, a critical problem remains: Mars's lack of a global magnetic field. Without it, the solar wind would relentlessly strip away our painstakingly crafted atmosphere, and the surface would remain exposed to dangerous levels of cosmic radiation, making long-term life extremely difficult, if not impossible. This is arguably the biggest technical hurdle in terraforming Mars. Several highly speculative solutions have been proposed. One involves placing a powerful superconducting electromagnet at Mars's L1 Lagrange point, a gravitationally stable point between Mars and the Sun. This artificial magnetosphere, like a giant cosmic umbrella, could deflect the solar wind, protecting Mars's atmosphere. Another, far more audacious and speculative idea is to somehow reignite Mars's molten core, restoring its natural geodynamo. This would require an energy source and engineering capabilities far beyond anything we possess today, perhaps even involving dropping massive nuclear devices or some exotic technology deep into the planet's interior. Whichever method, if any, proves viable, creating a permanent planetary-scale magnetic shield is a prerequisite for a truly stable and long-term habitable Mars. Without it, all other terraforming efforts are, quite literally, building on sand that will eventually be blown away. Beyond the staggering scientific and engineering challenges, the notion of terraforming Mars raises profound ethical and philosophical questions. Is it our right or even our responsibility to fundamentally alter another celestial body? Mars in its current state is a unique world with its own geological history and potential for indigenous, albeit microbial life. Planetary protection protocols currently aim to prevent Earth contamination of Mars. Terraforming would reverse this entirely, making Mars a human-centric world. What if there are subtle forms of life already there, adapted to the current harsh conditions? Our intervention could eradicate them. Then there's the monumental cost. Imagine the trillions, perhaps quadrillions, of dollars and resources required. Could these resources be better spent addressing pressing issues here on Earth, such as climate change, poverty, or disease? And what would a terraformed Mars mean for humanity's identity? Would it be a new beginning, a testament to our enduring spirit, or an echo of our tendency to consume and transform, leaving our mark everywhere we go? These aren't simple questions with easy answers, and they highlight that terraforming isn't just a scientific problem, it's a societal and existential one. So, after exploring the incredible hurdles and the sheer scale of the undertaking, how truly impossible is terraforming Mars? Today, with our current technology and understanding, it remains firmly in the realm of science fiction. The timeframes involved are not decades or even centuries, but likely millennia of sustained effort across multiple generations. The energy requirements are immense, the engineering challenges unprecedented, and some solutions, like reactivating a planetary core, are pure speculation. However, the impossible has a funny way of becoming merely difficult with enough ingenuity and time. The scientific pursuit of understanding Mars, the development of new energy sources, advanced robotics, genetic engineering, and breakthroughs in material science are all incremental steps on a very long road. Projects like SpaceX's mission to make humanity multiplanetary, or NASA's Artemis program aiming to return humans to the moon and then Mars, are not directly terraforming Mars, but they are laying the foundational knowledge and technological capabilities that might, just might, make such a grand vision plausible in the distant future. Terraforming Mars might be the ultimate impossible dream, but it's a dream that continues to inspire us, pushing the boundaries of human ambition and urging us to look beyond our pale blue dot. From creating an atmosphere and forming oceans to shielding an entire planet from cosmic rays, terraforming Mars is a challenge unlike any other humanity has ever contemplated. It's a testament to our species' boundless ambition, a vision that forces us to grapple with questions of technology, ethics, and our place in the cosmos. While it remains a distant dream, the scientific questions it poses drive innovation and deepen our understanding of our own planet and the universe. What do you think? Is terraforming Mars a noble pursuit or a fool's errand? Let us know your thoughts in the comments below. If you found this journey to a future Mars as captivating as we did, be sure to smash that like button, subscribe to Orbital Arc for more explorations into mission science, and hit the notification bell so you don't miss our next voyage into the unknown.